1.
This is the Wisconsin Lighting Lab WiLLcast. My name is Adam Rupp, and my guest today is Mike with WPGA. Mike, welcome.
Thank you for having me.
Absolutely. So, Mike, let's get started. Tell me a little bit about your background in the lighting industry and the lighting business and what WPGA does.
So I started out in the communications and semiconductor industry. I made a transition into lighting about 7 years ago, and I've been able to maybe utilize some of that background in an adjacent industry into the lighting space. So I have background in power, communications, and now a lot of background and knowledge in the LED space as well. And so WPG is a components distributor with a focus on lighting application specific.
So up until maybe 10, 12 years ago, the lighting business was really separate from the rest of the electronics business that you had some experience in. And with LED, those two worlds seem to be merging a little bit with solid state electronics. Is that a fair statement?
Yeah, they're merging incredibly.
Yeah.
So I think a lot of the initial development investment by the Department of Energy was to, give some resource money out into the market to move it along. So they needed to hit that power budget, right, to reduce power consumption and lighting specifically.
Sure.
And now lighting space, because of the adoption of LEDs, there's a lot more technology just around driving those LEDs. And so control and other spaces are all looking at that. And it was always DOE's concept and goal to achieve power reductions through the solid state lighting efficiencies, but also through control. So both of them together are going to get them to what they initially set out to do.
As far as the control side of it, how far along are we in that process as an industry? I know different companies are probably further ahead than other companies, but in my mind, it seems like that has really just begun. LEDs from you could look at a lumens per watt standpoint, you could look at an adoption standpoint. Things, the technology seems to be leveling off a little bit where you don't hit those huge gains in efficiency. And now it seems like the next wave is getting the gains on the control side.
Yeah.
Where are we in that controls process? Is it still the early stages or is it mature?
Yeah, so the controls, I think, were introduced right along with the LEDs, but
Yep.
people just focused on the LED portion. I think from my perspective, the market and the industry had a lot to get used to, where people didn't really pay attention to color temperature.
Yeah.
Everything looked good.
Yep.
Now, fast forward over the last 10 years, everyone's very familiar with it and want to see more features in their lights, and there's been the studies that have been done that show how that helps with productivity in the business place or in just at-home living. And so the controls, I think, were mostly focused efforts by the bigger lighting suppliers that had the resources and engineering sources to work on that. So it's been there for a long time. But I think the industry now is at a stage like we have a handle on the solid state lighting, the LED, the quality of light and the type of light, and they have now the need for this control, and the control will add for cost savings, and DLC is implementing their service to give you a certification that allows you to get the rebates if you use controls.
Yeah, it's interesting along that line. So I've been doing this for about 10 years now, and I remember when we first started selling LED as a distributor, I don't want to say it was easy to sell on efficiency, but the ROI was so fast, going from 1,000 watt down to 300 watt or 400 watt down to 120 watt, where the customer would get such massive gains from LED only. It was sometimes challenging to sell them on a complicated control system to get that extra 5%, 10%. And then on the solar side of things, solar has obviously been around for a long time, and we would have customers that would come to us and say, "Hey, I want a solar solution." And, we didn't have any solar options. And part of what we would walk them through is say, with this one product, this one fixture, you can eliminate 70-80% of your energy costs.
Right.
To get that extra 20% in a solar solution, you incur a lot of maintenance. The system gets more complicated. And I see controls now where, that's the next wave where I think the controls costs have become, the cost is lower. There's probably from a contractor expertise or kind of I call it, the contractor geek squad. Like there's people that have more of an understanding how to manage the control side. So I think the market's now primed for that.
Yeah. So that's what I'm looking at is not only what's happening in the lighting space, but there's things in the adjacent industries that are people in the lighting area will make use of that.
Are you saying like telecom or what other types of, I guess, industrial or commercial products?
Well, so one that's is having probably the most impact, IoT, right? So that's been adopted by a lot of industries outside of lighting space, and what they're trying to do is to make controls, interoperable. And so, a big concern anytime anybody's like a company brings a product to market and is dependent on another company for that to operate, then that's a point of concern.
Absolutely.
Right. The idea of Bluetooth Mesh SIG is that, there's a number of companies making those chips. If they're all SIG approved, I don't need to worry about my semiconductor company disappearing on me.
So more or less in the lighting space, for whatever reason, you have people running in a lot of different directions. Where could be consumer products, retail products, there's more standardization around those IoT products.
Mm-hmm. Yeah, so IoT is going to bring, or it's attempting to bring that standardization where they've developed in other marketplaces to lighting. The technology that's out there today is pretty proprietary.
Yep.
And so you've seen it out there, but you pretty much have to depend on that company and hope that they continue to support you. There's always issues with legacy products not interoperating with the new products they bring out. It's a struggle, right?
Yeah, I had Synapse. They're a smart lighting and controls company on the podcast a few weeks ago, and their system relies heavily on Zigbee. So they more or less have a Zigbee application that they've built, on top of the Zigbee protocol, and they seem to do a really good job with non-video, non-data. Mm-hmm. So is it true that the bandwidth in Zigbee is much lower than Wi-Fi or Bluetooth, or what do you see as kind of the competing technologies and functions within those?
Yeah. So what's really what's nice out there in the marketplace is the amount of technology that's been developed.
Yep.
And I don't think any of us think it'll be one or the other.
Yep.
The transport mechanism, it could be wireless or wired. And so there are a number of companies out there that have power line communication solutions over AC.
Really?
Absolutely.
That's pretty cool.
That was early targeted for meter reading. And now there's a number of lighting OEMs and chip manufacturers that have introduced product where you communicate over the AC line.
So the AC has to both power the fixture and more or less communicate with the network?
Yes.
Interesting.
Yeah, so they have basically that's what you're kind of looking with power over Ethernet. Now that's a DC-based distribution, so there's communication for DC and also for AC.
Awesome.
And it can go up to 10 megabits or higher. So in communications, there's always a trade-off with anything. The higher your bandwidth, the more susceptible you are to interferers or other people or noise, right? So slower speeds are a little bit more robust. So if you look at the wireless Loren system, it's very low data rate, but it can broadcast easily 20 miles, 25 miles line of sight.
Wow, that's amazing.
Yeah.
And I want to get more into the controls stuff and IoT. I want to just talk a little bit about LED chips themselves. And I know, the LED technology has been in the U.S. market for a while now. And when we first got into it, there there were major gains in efficiency and lumens per watt that were being picked up. I remember when a 400 watt metal halide replacement in LED was this big. Now we have a 75,000 lumen fixture that we're coming out with that's way smaller than the original 400 watt replacements were. So do you see the efficiency gains indeed leveling out on the chip side? Have the resources at the different chip companies been directed elsewhere, or are they still pumping investments and resources into making LED technology more efficient?
Yeah, because I can draw a parallel to the efforts that I see in this space to other semiconductor industries. And as long as there's a market and people can realize enough margin in their product, they'll continue to invest in the fabs and process improvements. All of them right now still have a lot of process improvements. And also, there's also equally large investment in the packaging technology too. So you're developing your fabs, your wafers, improving that, but you're also having to adopt new packages and things like flip chip or other technologies that way to help
making it easier to integrate into the fixture architecture.
Yeah. So, you look at some of the people out there with 220 lumens per watt. That's going to continue to creep up as people still want to have. Basically, I look at it as we're delivering photons, and people want to have more photons for less money.
Yeah, it's hard to argue that.
Yeah.
So. and as far as LED technology being deployed to end markets other than general illumination, I know there's companies that are coming out with LED products that disinfect operating rooms. Coming out with products that even some of the RGBW stuff. I mean, LEDs are being deployed for things beyond parking lot fixtures, high bay fixtures. Even you have sending data over Li-Fi. What are some of the cool applications that you guys are seeing in the market that people are using beyond just making a fixture light up?
Well, for around LEDs, the light source, I think everyone right now is basically they're able to adopt some of this new improvement because it's kind of evolutionary. It's not revolutionary, so they can keep.
It's a good way to put it.
They can keep their products up with the rate that the LEDs are improving. And so in some spaces, I don't think that it necessarily causes a huge dramatic shift in the product that they release this quarter to the next quarter. It's going to have some improvement, some cost improvement. So their order SKUs just maybe add a new product that a customer can take advantage of that. So I'm more looking at the revolutionary things that are happening to what's really going to impact that. Right now in the LED landscape, there is a new packaging technology that people are very interested in it and exploring that, and that'd probably be the most revolutionary. The flip chip and surface mount LEDs.
So what about like healthcare end markets? I see LEDs being used for red light therapy. For it could be skin problems to again disinfecting things or treating other ailments. Have you guys been involved with any customers that are doing some of those more cutting edge kind of use cases for different end markets?
Yes, we have been looking at the UV space. Yeah. And I'll say that the UV LEDs have some tremendous hurdles to overcome.
Really? Okay.
Yeah, UVA, you get into deep ultraviolet, which is in the 400 nanometers. You can kind of build a product that can do disinfection that's really kind of out of the UVA space. That energy, that spectrum's not so energetic, but if you get out into the 250 nanometer UVC or UVB, the LEDs are really struggling. They kind of remind me of what the LEDs in 2008 look like at 10 lumens per watt. Yep. They don't last long, and it's really a lot of material science needs to go into that to come up with some packaging that won't self-destruct.
So are they more or less packaging them or coating them with, is it additional phosphorus, or are they using other material sciences to more or less dial in that radiation wavelength, or what is it? Is it like we have on the back wall there, we have different LED chips from turtle friendly up to 7,000K. Is it the same technology to tune in those different colors, or is it a different material science altogether?
Yeah, so for us, we're in the visible spectrum,
Yep.
and that's important to us. So we use phosphor to create a broader spectrum, spectral distribution. UV and IR and even things in horticulture, one specific is monochromatic, so you're just at one specific wavelength. So there is no phosphor.
I see.
In fact, that's the best way to deliver the most photons. So typically it's just a clear coat over the dye for protection. So you'll just have a window. And so when you have and when you have these LEDs that aren't very efficient, like the old LEDs,
Yep.
they create a lot of heat and
Yep.
not as many photons, and that's what.
Like you said, they self-destruct then. Yeah.
Well, the energy at that
Yeah.
frequency is destructive.
I
That's
see.
why you can't leave things out in the sun, because it breaks down a lot of materials. So I think a lot of material science will have to go into the packaging. You can't use the same silicon that they package with the visible LEDs. So.
Cool. That's some interesting stuff. So switching gears now onto drivers and power supplies. So you come from the kind of the power business.
Mm-hmm.
One thing we've been doing a deep dive the last 12 months or so is trying to understand exactly why in some cases drivers might not last. We work on a lot of applications that are not friendly to power supplies. Could be 120-foot high mass light pole that turns into a lightning rod to, retrofitting LED technology on, grid technology that's several decades old. In addition to surge protection, in addition to we try and select the highest quality power supplies we can. What do you guys see power supply vendors doing to create more robust packages?
It's always a trade-off, cost and performance, and there's still the ongoing decrease in the cost of LED drivers, and most of them are AC to DC.
Yep.
I think what we are seeing are more companies looking at, again, talking about adjacent markets and influencers would be like this. Our infrastructure of this country is antiquated and overloaded.
Absolutely.
And so everyone's discussing smart grids. And if you look at renewable energies, windmill farms are distributing power via DC. And also South America, hydro dams, they have long DC runs. So I think we see a lot of lighting manufacturers are doing remote mount drivers. So if you can maybe look at reducing what you need to do in terms of putting protection on every fixture, if it has an AC to DC converter, and maybe move that back and put put a better protection on the one power.
Fix it upstream, right?
Isolate it from the rest, and then you're not putting redundancy and cost. And so we see some companies that are remote mounting just because of some of the form factors they have to meet. It's just not possible to get drivers. And we're working with a supplier that we're looking at a DC to DC converter that's 6 millimeters high, 50 watts. And so that's a simple buck converter. So there's ways to solve a problem without looking at the way you've been doing it to get there.
You really have to understand the whole architecture of what the fixtures being plugged into, not just focusing on the output, not just focusing on the light, but go upstream, understand, even a checklist for the contractor. Is the utility transformer outputting the actual voltage that it says it should? Does the distribution panel, is it up to NEC standards with proper surge protection? So,
right.
And that's where, as a factory, we don't always have that engagement with the local people that are installing and interacting with the products. But for some of these, what I call mission critical applications, we do have that engagement, with engineering teams, and again, trying to understand their entire system versus just the hot neutral ground the fixtures being plugged into.
It's interesting you bring that up, because that is one of the features that we have a couple of the suppliers putting into their products, abilities to monitor the incoming line and the output, and having a mechanism so you can pull that.
I think that's huge. When we talk about controls and power monitoring, and part of the problem is, if there is an issue in the field, it's getting everybody on the same page. So we can, a lot of factories will say ship the product back. We'll send it out to our labs. We'll have a lab analysis done, figure out what component failed, identify it was a lightning strike or it was some other upstream problem that caused it to fail, or maybe it was some type of part defect. More often than not, it's some type of over voltage problem. But if there is a monitoring device on board or even at the bottom of the pole to be able to say, hey, this thing saw 20,000 volts, or it sees 20,000 volts every time the laundromat starts up 3 blocks away, that at least gets the messaging, gets people moving in the same direction. And yes. I think that's an important problem to solve.
Yeah, all of us having been in this business, a lot of the installs are where you have most of your issues, and trying to understand it from returning one component.
Yeah.
Very difficult.
It is. So back to smart lighting and controls. One of the things that we talk about a lot is 2 or 3 years from now we'll be way more of a computer manufacturer than we are a light fixture manufacturer. And what do you see as kind of that tipping point in the market where light fixtures go from their primary function being producing photons to a secondary function, or it might be the third thing that people think about when they buy a product? I mean, what has to happen before that happens in the space?
Yeah, so I think a good example that exists out there today is building control, building automation, which is the furthest along. And there are building automation companies obviously adding a lighting component to their product offering. I think for lighting, it has a different cost point in the industry just because of the nature of what it is.
Sure. And
so there has to be something available for lighting that doesn't add too much cost where the OEMs and the installers can't afford to put it in.
So in that case, the computer, the processor, is at the building management level, and your sensor suite is at the fixture level. Because if you start to have redundant computers in a warehouse, it's going to get pretty expensive.
Exactly.
Yep.
So and you don't need necessarily some of the control that you may need in another industry. Some of that does need to be looked at.
Yep.
Like an HVAC needs to be monitored a lot. If you're not going to do data auditing reports for your fixtures, then you don't want to buy a lot of overhead, and you're not going to want to connect that into the cloud. So the IoT space, they're addressing both of that, and so the nice thing is that they are entering with more cost-effective solutions. They're trying to reduce the complexity, and I think that's the kind of learning curve that's going on, is how do you commission these products, set up the zones.
Yeah, absolutely.
Who does that? And if everyone's software is different, there's not really one expert.
And we see that a lot in the sports side of things. Is we had some contractors and distribution and agency partners up here last week, and we were kind of showing them the next rollout of our product design. And in the contractors world, they want as much to be done at the factory as possible.
Right.
They want to install the sports light on the existing crossarm, on the existing wood pole, and they want to hit the go button, and they want the thing to work. They want it to be, if there's zones that are needed, if there's packages for light shows, for other things, they don't want to be programming in the field.
Right.
So that's where we're really looking at, how can we make, if we can solve problems upstream at the factory and make the installer's life easy, that's really good for everybody.
Yeah, and I can see why you think you're going to be in the computer space, because if you're offering those products to the market, you're going to have to be the one that
that's a good
services that and provides that maintenance contract. So this is like the enterprise server space for Amazon that has a 22 megawatt server farm down in Tennessee.
Yep.
The companies that sell those servers, rows and rows of servers, they have the sale of that product, but then they have a post sales where they talk about maintenance.
So in those cases, is it still the electrical contractor that's doing the install? Or I know there's a voltage range where it's more of an IT professional versus a contractor. But I also think that sometimes muddies the waters a little bit. From a legal standpoint, a licensed contractor has to install AC products. But with a server farm, in theory, it's all low voltage. So it's a different market, a different skill set. Is my understanding correct on that, or who does those installs?
Electricians.
Electricians, they do.
So it is low voltage, but in the space of industrial low voltage, that space is low voltage is up to 1,000 volts.
Oh, wow.
So the data server farms have actually been using 300 and 600 volt distribution for quite some time, and that is pretty efficient way to transport a lot of power. And so then you need electricians there, and they had to overcome things like DC arcing that starts to happen around 350 volts. So there are insulated wire and connectors, switches mostly, that'll burn out from the arcing that occurs at those voltage levels, and they've overcome all of that.
So Mike, your time, are you lighting specific, or and it sounds like you have really good insight and perspectives into other spaces. But I know your company works on pretty much anything electronics. But
Sure.
Is your time specific to lighting?
I am. So
Okay.
like I mentioned, we're vertically focused on a couple of markets.
Yeah.
I'm involved in the lighting segment, and so I take all that previous knowledge and see where we can apply it into the lighting solution space.
That's awesome.
Yeah.
So I know you've got some notes. I don't know if there's anything you want to go through, or any topics that we should touch on.
Just back to the remote power, I was looking at that. One of the things that people are doing is more and more, if you do a remote mount, you do a driverless fixture. And so the power in the fixture is changing from no driver, no power supply on board, where you just run 48 volts or something less to it, to where they are putting maybe just the DC to DC in there, or they have AC running to a circuit on board, driver on board. And so I see people experimenting a lot with various technologies because they are available, and maybe it suits their applications for what they need.
So if there's a DC to DC power supply on board, isn't that still a failure point at the fixture that would have to be serviced?
Right. So if you look at AC to DC, it's a much more complex device.
Sure.
And so what makes a LED driver different than a power supply is that it does need to meet some lighting specifics, so power factor correction, and you have a dimming circuit typically in there.
Yep.
All that adds money. So if we just put a simple buck converter on there, that's really a small footprint bill of materials, much lower cost, better efficiencies. It's not having to deal with AC anything, and so it becomes a nice, convenient little driver. It gives you basically what you're looking for, which is tight tolerance control on the constant current output.
Is that more or less stepping up the voltage at the fixture, or
no,
is it
bucking down?
Bucking down. Okay.
Just buck down and keep it a very simple circuit that's not having to deal with a whole lot of things. So in that, I was looking a lot at the DC space, and in automobiles, the issue they're struggling with is they have 350 pounds of copper wire in a car today. And it's like almost
sounds expensive.
It's 5 miles of wire. Yeah.
Yeah.
So there's companies that are very big in that space making these wire harnesses, and it's getting so complex out there with all the automotive manufacturers that you don't really have this one harness for everybody. You have thousands of harnesses, and so they want to reduce the wires just from a manufacturing standpoint, and installation needs to be simpler. Hooking these harnesses into the vehicles is also a challenge, especially when you have to switch over to another model.
Sure.
So they're looking at power line communications, and DC is, so they have developed some very robust power line communications for DC to reduce that wiring and put the communications and control into the power grid of the vehicle.
They just need to make a big giant integrated circuit.
Yeah.
Right?
They are, and in fact, there's institutes in Germany that are material-based research centers. They're doing interesting things with the automotive industry to actually inlay conductive traces into the body of the vehicle. So on the door panels and on the fender panels, they can put down a groove with a plasma cutter, lay the material, whatever it is, it's hardened by UV.
Interesting.
And then it becomes conductive, and there's no wire.
So what happens if there's an accident and it breaks the circuit?
Yeah, well, yeah.
Maybe they should put it in the carpet on the floorboard or what. That's interesting stuff.
Yeah.
Well, cool. What else you got? Anything else we want to run through?
No, I think that it's, for me, I would just leave with that it's very much changing out there for
Yeah.
controls now.
Yep.
And I think the IoT space has really helped to move everyone that's been doing controls one way to really start considering a more industry standard way of doing it.
Awesome. Exciting times.
It is.
All right. Well, thanks, man. Appreciate it.
Thank you.
Yep. Thank you.